be working for me to create water, this process? No. Because what would I be making more of? I'd be making more hydrogen and more oxygen. I wouldn't be making water. I'd be getting a hydrogen and oxygen. If I wanted gas, that'd be great. But is that what I want? No. So whatever I'm doing would not be working. Okay? So I would need to use things like we talked about yesterday to try to shift my equilibrium so that I could make more water. Because the process I'm currently using has such a low value of K. All right? That has a low K. Okay? So that means I'm getting very little water. And because I'm getting so little water, this process is not working for me. I'm going to die a shriveled up, dehydrated mess on the island. Okay? So I can change my concentrations. I can change my pressures. And today we're going to talk about how we can change our temperature to try to get the equilibrium to shift one direction or the other to make more water. But right now, as I have things set up with this low K, am I making much water? No. Now, in B, if this was my K right here, and I'm trapped on a deserted island, what would you say about my ability to make water? We're doing pretty good. We're going to survive. If this was my K, and I'm trapped on a deserted island, I would look at that and go, okay, what am I making more of? Because K is much greater than 1 this time. Yes, my dear? One, two, who do you want? You lost it again? Yeah. Dang. Who'd you hit this time? Never mind. It's grade related. You didn't hit anybody. I'm glad to hear the car survive. All right. So, if you have a K that's much greater than 1, all right. If the K is much greater than 1, what phase? The product. Okay. So this time you have more product and you have less reactant. So what am I going to have lots of this time? That's right. You're going to have more water, and you're going to have less hydrogen and less oxygen. Okay? Everybody okay with that? So if we were trapped on a deserted island, this time we're making more water, less of the gas. Okay? So we would produce stuff that would let us live. Are you with me? Okay. Now the part we didn't get yesterday. So, assuming that this is our reaction, right here. Ignore the full number. That goes with today's lesson. But it's in here because we're going to do this today. First of all, based on what we've learned, what would you say about this reaction? Is it endo or exothermic based on its position? Okay. That tells us it's exothermic because it's a what? I know it's energy. Is it a reactant or a product? That's right. It's a product. That's how I wanted to know how you knew that. Gotcha. Okay. You knew it was exothermic because it's a product. Okay. Now, thinking about what we talked about yesterday with pressure. What is the rule for pressure before we talk about even the question? So if I add pressure, what does it shift to? To the side of fewer moles. So if I increase pressure in the question, write the rule up here. If I increase pressure, I go to the side of fewer moles. All right. If I decrease pressure, I go to the side of more moles. Okay. Those are the rules we wrote down yesterday. So if we look at A, what happens to hydrogen if pressure is increased? Well, I'm asking you what happens to the concentration of hydrogen if pressure is increased. So, pressure is increased. Is the equation balanced, first of all? No. That's the first thing we want to do. We got 3 H's, 2 H's. Let's put it this way. Let me change color. Alright. Put a 2 and a 3. Alright, so what do we know about our moles before we even read the question again?
4 more times.
Okay, so there are 4 moles. 2 moles on this side. Alright, so what happens to the pressure if it's increased? Well, we go to the side of what? So, we shift to what side? Okay, you shift right is one way to say it. Nothing wrong with that way. You can say it the way Nada said it. You can say product. Both answers are correct. You shift to the right or to the product side. Either one is good. Okay? Is everybody okay with how we figured that out? Okay? Okay. Now the question is, what happens to the concentration of H2? Now, this is true for everything we're doing today. Every time you say to me that it shifts to the right, whatever's on the right will increase, whatever's on the left will decrease. It doesn't matter if we're talking pressure, temperature, or concentration. Whatever is on the right side that's a product will increase. Whatever's a reactant on the left side will decrease. If you say that it shifts to the left, whatever is a reactant over here will do what? It will increase. Whatever is over here is a product will do what? It will decrease. So you have to analyze your reaction and say, am I a reactant or am I a product? Am I a reactant or am I a product based on, did it shift right or did it shift left? That's what you got to look at. What did you just say? This is based on what you said. Okay, this happens all day today. If you say it shifts right, it does this. If you say it shifts left, it does that. It never changes. Okay? These are the what? These are the what? So if you tell me it shifts left, these are still the what? Still reactive. These are still the what? Product. Okay? So, in this question, you said, what happens to hydrogen if the pressure is increased? Pressure is increased, you guys said goes to the side of fewer moles. What side are the fewer moles on? You said the right or the product side, right? So, product, what did you say was going to happen? Okay. Whoops, wrong way. Superimpose that on top of your reaction. Where is hydrogen? Is it a reactant or is it on the product side? It's a reactant. Okay? Everybody got it? It's a reactant. Is it increasing or decreasing? Here on this side, right? So it's decreasing because you said it shifted to the right. Whatever's over here is decreasing. Everything on the reactant side is decreasing. Everything on the product side is doing what? Increasing. And that's the answer. It's hydrogen is decreasing. Okay? So the answer is hydrogen decreasing. That's the answer. They want to know what happened to hydrogen. Hydrogen decreasing. You okay over there? Okay. So what happens to nitrogen if pressure is decreased? All right, so we're asking about nitrogen this time. This one right here. So if pressure is decreased, what's the rule? So it goes to the side of more moles. So if pressure is decreased, we're going where? More moles. Where's more moles? Okay, so we're going left or reacting. Either answer is correct. So we're going this way, right? So again, superimpose this right here on top of your reaction. So you've got N2 plus H2 goes to NH3. Okay? And I didn't put the balance again. And I'm asking you what happens to this? It would increase. Because you said it shifts left. So everything on this side increases, and everything on the product side does what? So N2 increases. So the answer is, wait again, N2 increases. Does that help at all? Okay, so we do 3. All right, what happens to HI if pressure is increased? A balance. Good God. Dead people not for third series. It's not even about third series. Dang. How do you do that? I don't know. Only third series. You know that. That's my question. What do you do? Well, I put it there. If I remember what I said yesterday, this is the only one that can have what? No change. Guys, this is the only one that can have no change. And the reason it can have no change or no effect is because this is the only one that's based on coefficients where the coefficients can be the same. Okay, concentration is not based on coefficients, nor is temperature. And so those two cannot wind up having a no change or no effect. It's only pressure. Okay, now, since we're reviewing where we were yesterday, let's take the same equation. All right, and I'm going to add an addendum here. You don't have to do it in your opening, but just so we can review for a second. Let's take number 3. All right, and I'm going to say, let's add H2. What happens to HI's concentration? Okay, we haven't done a concentration question. All right, we're going to add H2. What happens to HI's concentration? Think about it like it's my yogurt on the fridge. Say what now? I mean, we're at equilibrium. What size is H2 on? Okay, so the rule is when you add anything, it goes to the opposite side. Okay, so what side is H2 on? It's the reactant, right? So it shifts to the right or the product side. Doesn't matter how you say it. Okay? So again, superimpose what we just said. You said it shifts right. Superimpose this on top of your reactant. You got H2 and so on. H2 plus I2 goes to HI. Which compound am I asking you about? I'm asking about who? What happens to HI? So I'm asking about this one. So what happens to it? It increases because it's here. You said it shifts which direction? You said when you add H2, which is here, it shifts to the opposite side. The opposite side is the product, right? The product is here. What happens if it shifts to the right? It increases. Are you with me? It's a lot to keep straight. I know. That's the downside to Le Chatelier. Okay? All right. We're going to do temperature, then we're going to practice. All right. Let's do temperature. So we've got all the rules together, and we have finished the note, and then we're going to practice. And I'm going to look up what time we get out of here so that y'all can keep me straight. So around, I think, 9:35. We all want to go home.
I'm going on.
You have to you will need to watch on YouTube catch up.
Well, how long is
An hour. Yeah, an hour. You watch an hour?
Yeah,
I think that's just consider, but I will look.
Oh, I think you get this note. Yeah.
Even though it's taking very good notes, by the way.
Yeah. I just look at an example and
That's what I look at. I don't even look at. I look at what I'm talking about. I don't know. Those are my good sports.
I don't want to do that because I'm not. I try very hard not to do that. It isn't Christmas season at all, but your brain's not all that stellar. So perhaps that's just in yourself. What can that brain to do? Okay. I mean, I don't know. Martin's not here. Mario's not here. Yellow's not here. So, you said, y'all better, no. Permission 4.
I don't want to talk about it. Whatever you just
It's fine. I was just on your book. I just rolled by because I literally just marked you as like 15 seconds ago. It may not have been 15. There's paper over there. I'll even loan you one of my pencils and pens. Then you go up to that. Here. How about a purple one? Paper's over there. This is the here. You have my wrong there.
Yeah, I was thinking of the one.
What kind of? I appreciate it. It's not my favorite. I certainly don't want to waste something. Oh, yeah, I have to go back. Yeah. My brother brought home the rest of the food. Yeah, chicken. Are you planning to be here tomorrow? Are you not showing up with Tyshawn and Ethan and the rest of them who are bailing and trying to talk Emma into being a terrible child? Don't listen to them, by the way. Don't bow to peer pressure.
Wait, hold on.
We're the only one that's not gonna be here.
I know. Because I need a rest.
We all need a rest. You're the only one.
Exactly.
We all need a rest. No, I really can't. Sometimes you see, I'm going to like take my mental health about in the fall.
We all need a rest. You think I don't want to be here?
Exactly.
Both my nephews are already out of school.
I know somebody's like, well, I'm still on that.
And I'm still here. Yeah, I'm a little bitter about that. It is disgusting. A little ill about the whole thing too, by the way.
Alright, well, I'm gonna write these things, maybe I will understand that I have to ask you a bunch of.
Yeah, you'll have that.
Oh,
Right, whatever color you want. Yes.
I'm going to get it for a while. I want to know rain.
Yeah. We'll talk about it later. Yeah. Alright. it's fine, stop. So, if we remove heat, okay? If we remove heat, remember, these systems are at equilibrium, okay? Again, these are at equilibrium. Talked about this yesterday. So to review, they're at equilibrium. We are disturbing the equilibrium. They were perfectly happy. We came in and removed the heat and upset the equilibrium. So these systems are trying to get back to equilibrium. Okay? They're trying to get back. So how do they get back to equilibrium? Just like yesterday, if you remove the heat, this part that's not in bold is the reason behind it. So if you remove the heat, it's got to add some more heat in to get back to the equilibrium. Okay? So the bold is the rule. So to get back to equilibrium, to add the heat in, it goes to the warmer side. You're going to love this. An easy trick for you on this one. Here's an easy trick. All right, this one I forgot to bold, so I'm going to underline this one. All right, this is the bold. All right. Now, if you add heat, as in you put heat in, you have to shift to a side that will take away, okay, or absorb the heat. So you go to the colder side. Now, some people actually prefer temperature when I finish. Like, why didn't you teach them in person? Well, they always tell me at the end, some people think concentration is the harder one. They don't know why I started there. So you tell me what you think after we finish. Now, most of this is review. You probably don't need to write, okay? So I'm just hitting some highlights here. So stop writing for a minute and listen. You may not need to write any of this. So, first of all, don't write that at all. Then don't write that. I should have known she's involved in that. All right. Enthalpy means heat content. You already know that. It also has a symbol of delta H. You already know that. Why do you write that? Okay? If delta H has a positive number, it means it's what? Endothermic. If delta H has a negative number, do we need to write any of that? No. Did you stop writing over there? No. Are you still writing? Okay. Now, you shouldn't have to write this either, so stop writing. Now, endo and exothermic can be determined by their place, just like we saw in the opening, I think. All right, so we had reactants plus heat on both sides. Now, in the one that I showed in the opening, instead of writing heat, I actually put a number in it, right? So if it's on the reactant side, that tells us it is endothermic, and if it's a product, it is exothermic. We don't need to write any of that, right? Very good. Oh, y'all didn't need to write any of that. So here's our example. Now you need to write it. So this part's going to be the example. What?
No, last night I was thinking. You know what's hilarious? I said, you only did one. You still only did one.
Really?
Yeah. But I thought I only did. She was still only this morning. You woke up on that when we texted her.
Yeah, you said I just look up right now. I'm gonna finish that, and I was like, okay. I never seen. Can I take the place? I should have done my foot.
I need to go with the water.
I tried. It's
They open that.
All right, we got up? No. Well, I'm gonna put a question in there. All right, so let's say we add heat. All right, let's say the question asks, what happens? Wait, what time is it? It doesn't really matter. I'm gonna add it to the whole reaction. What happens to oxygen concentration? And on this one, we'll ask what happens to what happens to water concentration. That way, after we shift, we can figure out what happens to concentration. Because again, just like we said a second ago, did I change the board for a moment or do I need to wait? Everybody got it? If you say, yeah, y'all pick up. Those are the rules I told you we wouldn't learn in a first year class. If you say that it shifts right, nope. If you say that it shifts right, what happens to the product? They increase. What happens on the reaction side? It decreases. If you tell me that it shifts left, what happens over here? And what happens over here? It never changes. It does not matter if we're talking temperature, concentration, or pressure. It does not change. Okay? This is the same thing I wrote down when we did the opening. Okay? The exact same thing. That way, if you didn't write it in the opening and you want it in your notes, you got it. Okay? Plus Danielle wasn't here. Now, everybody got it if they want it before I go back? All right. So, I said we're going to add heat. What is the rule? Yep.
It will go to the colder side.
Okay. Goes to the colder side. Told you I had a cool trick. This right here is what? Okay? Now, that's the energy or the heat. This is, essentially, we all know it's the exothermic reaction, right? Now, if it's exothermic this way, we know it's endothermic that way, which means the reverse reaction is the colder side, correct? Now, you can go through the process of figuring that out every time if you want to, which is completely cool. However, that's the long way. If this is the heat, that's the what? That's the warm side. Okay? That's the warm side. So, if you know that that's the heat, and that's your exothermic side, and the opposite pointing this way is the endo side, because we just figured that out, that means that this has to be the what? The cold side. So basically, when you are doing heat, if you see the number, or the energy or the heat, that's the hot side, or the exothermic side. Okay? So, what happens when you add heat? It goes to the side without the number, or the heat. So what side doesn't have the number or the heat? Okay, so it goes to the left or the reactant. Either answer that I heard is right. Without. Oh, I was writing that and then I erased it. Because I had a line that looked odd. Let me fix that. Without. Alright, the side without the heat. Alright? Huh? It doesn't matter. You can put, say that again. You can put without the heat, or you can put left or reactive. Any of those will work. Yeah. Okay. So, my original question is what happens to oxygen? So, if you know it goes left or towards the reactive, what happens to oxygen? All right. I hear increase from Tachon. What do the rest of y'all think? Okay. I agree. You think increase. All right. Now, if you don't agree, from Greg. Over there. All right. You said shift left. You had what? Equation I have H2 plus O2 goes to water. Okay. And I asked what happens to H2. H2 is where? And have increase. Everybody okay with that? All right. So if we go back, if I remove heat, you have to go to what? The warmer side. All right. So the warmer side is the side with the number. The warmer side is always the side with a number. So which way is that in this reaction? Product to the right. So what's going to happen to water, which is what I asked for in the question? Where's water in the equation? It's on the right. It's a product. What's going to happen to it? You said shift right. What's going to happen to water, which is a product? It's going to increase. All right, we're going to try practicing. Because what? Because it's that. If you remove heat, it always goes to the warmer side. The warmer side is the side with the number. So the warmer side happens to be to the right. You know that it shifts right. So when you know it shifts right, what side is water on these two? Is it a reactive or is it a product? That's why you know it increases. Yes, ma'am. Yes, you can. Take that. Back up the door. Where's going with that? Oh, no, that's. Which one? I don't care. They have been drugs through probably every bathroom in this building and along every floor. It's like, I don't think either of them is knocking them away. Gross idea myself. People take the bathroom. Last part of what? I can turn it in my part. All right. So turn to the back side of the worksheet based on where the holes are. All right. The front side is calculated K, which we've done, and I've already given you a quiz on it. I'm getting ready to hand back to this one. While y'all work on it. We've already calculated K, so unless you just want to practice calculating K, turn to the back side, which is what's got the principles. All right. Now, the first one's already done for you. Let's talk about number 2. All right. If you add hydrogen, okay, what is the rule for adding anything? That goes to the opposite side. So where's hydrogen in the reaction? It's a reaction. So it goes to the opposite side, which means it shifts which direction? The right. in that first clause. Okay, now, what happens to your concentration of nitrogen if it shifts right? Again, look right here. If it shifts right, superimpose your reaction on top of here. What happens to nitrogen if it shifts to right? It decreases. What's the next one? Does it have a line there? That means we added it. You can't ask what happens because they just told you that. All right, what happens to NH3 if it's a product? So you would write increase there. Now, the last column asks you about K. What is the only thing I told you would affect K? Try again. Try again. Temperature is the only thing that affects K. So, you're going to write what there? Remains the same. For everything except what? Temperature. Now, when you get to temperature, all I want you to do is say temperature affects K. You don't even have to tell me how temperature affects K, because that part is not part of your curriculum. Okay? You can write temperature affects K. You don't even have to know how. You have to know whether it's endo or exothermic to know how it affects K, which would be this part. Okay? I'm not going to make you memorize the rules. Okay? We can, if you would like. I just thought we would skip that part. Because it's not really part of your curriculum. Okay? Now, I want you to try those, and then we're going to go over them, and then we're going to play a flip. Okay? Now we'll run around and help those who are just long. All right. I think I did no one else is coming. Can't think out. One thing about it.
I don't know how they do on the screen, and it did not move right.
Yeah. You're probably you've got time to understand endo and exo, but you don't know that exothermic. Whenever something is exothermic, that means they'll take the negative. Ever endothermic means they'll take the constant. You figure out the answer correctly, like increase and decrease, you understand that. So times on my stuff. Increasing is just as problem. Decreasing is just as negative. When it comes to figuring out if it's endo or exo, that's what you've done correctly. All right. Yes. This side side, that's fine. Right. Some pipe, I just don't know what pipe. I know you didn't really show up. I thought you were going to be more.
Oh, there was another question. I was wondering how that. On that? Oh, wait, you got them. Oh, you did really well. It's amazing what happens when you come to class and drive.
No, it's amazing what happens when you have a good. No, kidding, I'm not.
And he had a really good day. I can just put it right there. Why did you get someone home? Where's that? No, but they're right. Oh, that's where it's at. Hold on, let me finish what I'm doing.
I didn't say from that course.
First number 9.
Number 9.
I knew it was the A or C, but I didn't know you were out.
Yeah, the one we're totally talking about.
I was on that paper, I'm like, what is?
It's endotherapy, higher, and endo-4. The one that was most missed was 7. A lot of y'all picked high activation energy. It was C, because not everything has high activation energy. Some of them have low activation energy, like if it's exothermic, it can have low activation energy. It's supposed to have sufficient kinetic energy to have a reaction. It doesn't have to have high activation. I mean, some endothermic have high activation energy. Some exothermic have low. I know it.
Wait, that's wrong.
I didn't have much.
All right. So the one that you missed, about a second ago here, let's go back to what's that now. They found it flat. So it's a one, I don't know, 140. I did the right one. No, I know what you're going to do. So it's no, it doesn't matter. Yeah, so you can. Picture doesn't matter.
Even out,
Anybody else have a question on any hands back? Then you go work, we go good.
I might understand.
I think I looked, but it was 9:35, let me look again, maybe I didn't look, I don't remember somebody. Yeah, come here. I thought I was on your desk, so that's why that.
We'll leave it right now.
9:30. 9:30. Oh. And I said to somebody else,
Don't you like really like you?
Never go to like walk. Yeah, that's it.
That's it.
Yeah, we're outside.
No, just like you were there, friend. That's not so bad.
Oh, no. Oh, I thought it was
Did you really just ask him if that was a move ring?
Yeah, they would change the colors over there.
It's red the whole time.
Right, they changed the purple.
No, the lighting. You can't.
I know that.
Yeah, I got to see. No, like, in this, that's why I know I have all of you to do that. Yeah, you'll say, well,
All right, let's look at what you came up with. Find mine, so I know what the answers are, or the questions are really. We're all ready to go home. We're trapped like rats on a sinking ship. Hey, I made my fourth period by ticket to the talent show. We're stuck here. All right, so if we look at, we did 1 and 2, so we're on 3. So if I add ammonia, if I add NH3, what do I shift to? I shift left. So if I shift left, what happens to this? It increases. What happens to this? It increases. And this one should have a blank line through it. We said it would shift left if you add NH3. Okay? All right? Number 4, if I remove N2, the rule is if I remove, stays to the same side, so it will go to the left. So what happens to H2? What happens to NH3? Decreases and it stays the same. All right, the next one was H2. If I remove H2, it stays to the left. What happens to N2? It increases. What happens to NH3? And then K. All right, number 6. If I remove NH3, it goes to the, what happens to N2? Decreases. H2 and NH3 should have a line through it, and K, same. All right, if I increase temperature, what will decrease, same. All right, where was the temperature at? Plus 22 is here. I didn't write that in. All right, plus 22.0. So we're increasing temperature. If I increase temperature, it goes to the left. So if I go to the left, this will increase, and it will change. K will change here. All right. If I were to do that, decrease temperature, it will go to the right, and so this will decrease, increase, and K will change. Oops, okay. All right, hang this out of the way. All right, 9 is pressure. If I increase pressure, it will go to the right. So N2 will decrease, increase, and K will same. I don't know what I did there. All right. Not getting any better. And the last one, if I decrease pressure, it will go to the left. N2 will increase. Very good. All right. If you remember your Plicker card number, grab it. We're going to try a couple questions and see if we really do have it. If they're done not in sequence that way. Pronounce Mrs. It's fine.
And I think that's so weird how we're like,
That sounds so weird.
My daughter's appalled that my website says MS, not MRS.
really? I like MS.
I
I just put MS on everything.
You can't go wrong with that one. I don't know.
There's lunch. Are you kidding me? Yeah.
I think I'm going to. I hope I got
All right, check your numbers real quick. All right, our numbers okay before I take it down?
I don't know how to use the card. I play this. No, that's Pokemon.
Yeah.
My brother and my brother used to play Pokemon.
All right, all right, there's a question. I just didn't use brackets. Okay, you only did, you play three people, really?
Wait. Oh, no, yeah, okay, no, I'm good. I want to preserve your stuff. Oh, wait.
Wait a minute.
Oh,
That's 1/4.
Wow, I saw all the calories. Why do people do that?
I love sharpening my.
How many of y'all shopping out pennies?
No, what?
Sharpen them.
Okay.
No, like,
Yeah,
no,
kill somebody for it,
Like at the end, you're
like, when you're,
yeah.
All right, so we're 12-3. So when we look at this, what can we say about the heat?
It's going to the right.
So if heat is increased, it's got to go to the side without it, right? So it's going to the right. So what happens to?
I don't know, I said that, you said no.
You know,
Okay, so NO is going to. All right. Did I say it wrong?
Yeah, I said
I
it's going
think
to the
I
right.
did.
You said
All right.
no.
I think I did. So if heat is increased, here's where the heat is, right? So it's going away from it. So it's going to the right.
Right, yeah.
So NO is going to increase.
Okay, I thought, go for heat.
It goes the opposite side.
So if it decreases, it's what?
Huh?
What's it?
You're gonna go to the left. The answer is A. Those who said A have the right answer.
I thought you were wrong.
No, y'all were right.
I know, I thought it was decreased.
Oh, I know I didn't. Did I say decrease?
Yeah,
A is the right answer.
oh my God.
I don't know why. Y'all have the right answer. Yeah. So the heat was on the left. So it shifted that direction. So NO was going to increase. Yeah. Did I say that? No, I meant to say increase. Sorry, I didn't mean to say decrease. I'm sorry. Whoops, I mean hit scan here. Then my brain increase came out.
No? Yeah, no?
Huh? Well, I didn't get personal, so I thought it was paper on the news.
It's crazy.
Someone set it off.
Like, you're right.
Some kids go messing around. Everybody goes to messing around. And one to do the.
We'll do like fireworks. Come on, like, what's it like fireworks?
I'm like, that's how they
It was like right behind
me.
me. I think.
Alright, we didn't do too well on this one. Alright, so if pressure increases, what happens to the concentration of oxygen? Alright,
Move on.
if pressure increases, we have to do what? Okay, fewer moles is which way? How many moles I got here? How many moles I got here? So I have to go to which way? I have to go left. So that's going to increase, that's going to decrease. So what am I asking about? I'm asking about O, so what's going to happen here? O is where? Concentration of oxygen, so oxygen's going to do what? Oxygen's going to decrease.
I think there was I forgot there was no, I was wondering.
Oxygen's going to decrease. Okay? I know. It is tedious, which is why people don't like Le Chatelier.
His mental age is like 12.
Alright. We'll do about 2 more, then we'll stop. We only got about 5 minutes. We'll do about 2 more. I know, concentration is the one y'all hate.
I think like, remember what it
I don't know what this means, but. I'll take the same answer 3 times as well. Because it's like the opposite.
So what?
The opposite.
Yeah, you add, then it goes to the opposite side.
So,
I got it.
See, if you said add, I've got it. Yeah,
I gotta, see, when I think of it, I just imagine like a big scale of this little thing. Not right? Wow. Think about it like a scale.
Oh, did I put A? No, no,
Turn it towards me.
Water on this side.
And not me put A.
Right? You add more oxygen.
I didn't mean to
Yeah,
put
you add
A.
more H2O.
Alright,
I didn't mean to put A.
so, if you look at this, alright? If the concentration of water is increased, that's the same as add. If you add something, what does it do? It goes to the opposite side. So, water is here, so the opposite side is over here. So that means it shifts which direction? It shifts left. Okay, so if it shifts left, this side increases, this side decreases. So what will happen to oxygen, which is right here? It will increase. Okay?
If it goes left, why would it increase?
Because whatever's on the left increases. Every time it goes left, whatever's on the left increases, whatever's on the right decreases.
Why does it do that with all of them?
It just doesn't. If you say right, you've got to get this part straight in your head. This here never changes. It doesn't matter what we're talking about, temperature, pressure, or concentration.
Okay.
Okay, that doesn't change.
Figure out which way it shifts, so I did shift right, shift left, and shift right, so an arrow points to the right, and wherever the arrow points, that's what it is.
That is what will increase, yes. She's not wrong.
I just think about it like a scale. And
That's fine.
The arrow points left, wherever it points, that's it.
Yes, exactly.
I practice those.
Yes.
Click it off.
As long as you can figure out which way it points, that's going up. Whatever's on that side is going up. Okay? All right, nope, it's 9:28. So we've got 2 minutes before the bell's gonna ring. So if we can do one more of that real quick. All right, last one. This one should be an easy one. Let me get rid of all the crap on top of it.
We don't do that.
All right, this is an easy one. Got heat in it. All right, if temperatures increase, what will happen to the concentration of water? It should be an easy one. Pick an easy one. Got heat.
Already had it.
This was great. It better be right. I might be right here. All right.
That goes right.
I'm wrong.
What did you just read?
Wait, this my part?
I only got yours in can.
Oh.
Got Lexus can and yours. What you good?
Wait, if it increases the
Hands are away. Sorry. Yes, Ethan, yes, Catherine. Yes, no. I'm sorry, I didn't get your scan. Okay. Put your cards up here on the table. No homework tonight, other than studying the Chatelier. You'll have a test when you come back from break.
Like the day we come back.
We're done with new stuff, but for the test, but no, we'll not be today, we'll come back. We come back Wednesday, it'll be Thursday. When I told y'all, I don't do work over Christmas, I'm not giving y'all work over Christmas. All you have to say, the test will not be Wednesday, it'll be Thursday, the exam is the following Friday. You know where you stand and what you want for outcome. You choose based on
Oh, I thought you were about to say
I
that.
love
right?
that.
No, okay, so my brother over the weekend took us to Maria's friends, so we can pick them out. So I know what I'm getting for Christmas.
Oh,
Eat
that-
some chicken, I'm gonna make you feel better.
Yeah, I can't breathe, if I breathe wrong, my parents are screaming.
Yep.
My parents are Christmas shopping with mom taking off. I think that's what they're doing.
Can I have my sheet people to the front office, my sheet people to the front office?